Hello, everyone. I'm Leili Tavabi, and I work at Intel. This is a side project that we worked on with a friend of mine, Yasin, who wasn't able to make it here today, so I'm presenting on behalf of us both. Just a brief overview of the contents was that we all know after this workshop the importance of influential nodes and how it can be applied in different applications. So we're focused on academia and on the field of big data mining specifically, and we were using the publications from the recent years from big data mining conferences to predict and find the most effective research institutions in the field of big data mining. So as you may all know, one challenge here was that the results of the 2016 conferences were unknown at the time of the competition. So we didn't have any ground truth to evaluate our methods and our results against. And there was also big data challenges that we had to overcome, which we did by the use of Hadoop and Spark. And we were using Microsoft Academic Graph as our database for the papers of the conferences. So the team's approach was to find the scores of all the affiliations in this, using the same scheme that was provided by the KDD Cup across the recent years from 2011 until 2015, and apply a rank aggregation method across those rankings to provide a final and unified ranking for the 2016 submissions and the acceptances of the institutions. So, as I mentioned, the problem was that we didn't know what that ranking is, so we didn't know what rank aggregation technique would get us closer to that final ranking. So what we did instead was that we used 2015 results as a test bed. So we evaluated our rank aggregation techniques from 2011 to 2014 and saw which technique gets us closer to the 2015 ranking, and then applied the same thing across those full years to provide us with the ranking for 2016. So the rank aggregation methods that we looked at included border count, which is an intuitive election method and in which the voters assign scores to each of the candidates based on their preference. And these measures are based on how many number of candidates are placed after you in line. So then you use an aggregation method. It can be a median, a geometric mean, or a mean that you provide for all of those different voters and all of those different rankings to come up with a final and unified ranking overall. Another method that we looked at was Fagan algorithm. And in Fagan algorithm, given a number of rank lists, you do a sorted access on each of the lists in parallel. And for all of those items, you do a random access to all the other lists to fetch those items, and you do a sum, and that will provide you with a final ranking as well. The iteration stops when you've reached the K top items, and then you stop and you have your final ranking. And our final and proposed algorithm, which is the one we ended up using, is that you simply find the normalized scores for each of those rankings for each of those years, and do a sum for each of these institutions across the years, and that will provide you with a final ranking. So I have some results here, and these are the NDCG at 20 values for the different conferences and the different phase. And as you can see here is the proposed algorithm, which is the sum of the normalized scores, has better results and better scores comparing to border count and Fagan, which were the alternatives. So it's the same for phase 2. As you can see here, that it's generally higher for the proposed algorithm, and phase 3 as well. So that's the technique that we decided to go with. And so in general, using the affiliations and finding the scores, the affiliation scores, and then aggregating the rankings across the recent years to provide a final ranking for 2016 was our approach. And thank you very much.